Okay, so what is it? This is our weekly question show where I'm going to answer your questions about space and or astronomy. So go ahead and put any questions that you have into the YouTube chat. Just one time. So we have a database that tracks all of the questions that you've asked. So you don't need to, I should start the recording. So you don't need to, let me get that. Okay. Yeah. So you don't need to ask the questions a bunch of times. We see it. It's there in the database. We got it. But then go ahead and put the question in, and then our moderators, I see Zafan's here. I don't know if John Suffel's here yet, but they will grab those questions, put them into the database. I will be able to then see all of the questions and decide which is the one that I want to answer next. And so what makes me decide which questions I'm going to answer? Because we will get about 200 questions over the course of this show for the 2 hours that this is going to run. And so I have to decide. And so I try to put emphasis on for the people who've never had a question answered before. So if that's you, I like your chances. I also just need to remind you every week that I am a journalist, not a scientist. So, if you're going to ask me for my scientific opinion about some theory that's going on right now, like the timescapes, cosmology, or Mond versus dark matter, or any of that kind of stuff, I have no opinion. Like, I'm not qualified to give an opinion. I can give you reporting. I can tell you things that other people believe, but I am not qualified to give you an opinion. So just keep that in mind. And then the last thing is that, we get a lot of the same questions every week, and I really try to keep it fresh if I can. So it may be that you're asking a question and you just this is the first time you've been here and you don't know that people ask me what I think about UFOs and what's the great attractor. And I've answered these questions. Where's the center of the universe? These are questions that I've asked a bunch of times. So just keep that in mind. It's not personal. It just might be that I'm trying to keep the questions fresh. So awesome. All right. Well, with that out of the way, let's get into the questions. Yes, I am recording. Ever mentioned, we have a checkbox that I have to press when I access the database before I'm able to see it that says whether or not I'm recording. You know why we have that checkbox? Because I have done shows where I forgot to press record. And so, the little things you learn. All right, let's get into it. Oh, no. Huh. Okay. All right. Good news for you. The thing that shows me who's had which questions answered is not functioning. So I have no idea how many times you've had your questions answered. Although I do recognize some names. But anyway. All right. Billions and billions of stars. Any update on the Mars sample return? No update. But in the most recent NASA budget proposed by the White House to Congress, where they take the original NASA budget and knock it down by about 25%, down to about $18+ billion. They completely zero out any investment into the Mars sample return mission. So currently, there are no plans to conduct the Mars sample return mission, which is too bad, because Perseverance is collecting all of these samples, and it's ready to bring them, and nobody is going to be there to receive them. Now, this doesnent surprise me. Like, I think any administration would have taken a very serious look at the Mars sample return mission. This was pretty much the top requirement, or the top ask by the planetary science community in the most recent decadal survey. This is the thing they want, right? All of these pristine samples have been collected on the surface of Mars. Now we've just got to get them back into our hands. And that is, going to be a very complicated multi-step process that's going to require a lot of coordination between different space agencies and different missions and spacecraft and landers and ascenders and all of this to bring sample return capsules to make this happen. And so it is scientifically probably, incredibly important, but also it is very expensive. And so the budget had gone beyond $10 billion estimated. And someone, people said, okay, we got to come up with a new plan for this. That said, the Chinese are still planning to go ahead with their Mars sample return mission on 2028, bringing the samples back probably 2031. So we will get samples from Mars, but it's going to be a much more stripped down mission where the lander lands, scoops up some nearby material, maybe deploys a helicopter or a small rover to try and grab some additional material, puts it into an ascent vehicle, and then brings it back to Earth. And we will be able to have the first fresh samples of Mars here on Earth. And I think if what happened with the recent lunar sample return mission is any indication, hopefully these will, get out into the wider scientific community and more people will be able to study them. So right now, the plans for bringing material back is relatively slim. Of course, SpaceX separately is hoping to be able to send a spacecraft to Mars at some point in one of the upcoming windows. And then if they can do that, then maybe they'll be able to do a return vehicle from Mars. And then if they do that, then maybe what they can do is bring home the samples from Mars. But, I'm not going to, wait until somebody actually sets aside money and budget and says they're going to make this happen. Jim Ashby 43, what is the speed of the fastest galaxy that we can see moving? Are we able to tell the speed? Thanks. So the fastest galaxy that we know of is redshift like 14.3. And there's a great website that I really like called Ned Wright's Cosmological Calculator. I use this all the time. And you put in the redshift number, and then it will tell you sort of more easily digestible numbers. And so, for example, that if you have a galaxy that's seen at redshift 14, then the age that you're seeing the galaxy is at 300 million years after the Big Bang. And that the light has been traveling for 13.4 billion years to get to us. But obviously it's not 13.4 billion light years away from us. It is now 33.7 billion light years away from us, because that is called the co-moving distance. That essentially the galaxy has been moving, we've been expanding away from that galaxy, that space itself has been expanding between us and that galaxy. And so if you could just instantly teleport yourself to that galaxy as it looks today, you would be traveling over 33 billion light years to be able to get there. But the question you asked is, what is the speed? And the speed of the galaxy is faster than the speed of light. It's about 2.5 times the speed of light at that point. And so right now, if you set off at light speed to try and get to that galaxy, it would be receding away from you faster than you could never get to it. And so even though we can see it, even though the light has begun the journey to get to us or is finally reaching us today, we cannot access it. It is over the cosmic horizon from us. And so, when you think about the, how far away are galaxies where they're actually traveling faster than the speed of light, it's about redshift 1.4. And I don't know what that is, what the co-moving distance is. Hold on. So 1.4 is 4.5 billion years after the Big Bang. And so the light has been traveling for 9 billion years. So if you see a galaxy that is about 4.5 billion years old, then it is now traveling at about light speed. And so, but that's even we can really only reach about 4% of the universe now, because the rest of it is already sort of either already going faster than the speed of light from our perspective, or by the time we reach it, it would have gone faster than the speed of light if we were traveling at close to the speed of light. So actually a lot of the universe that we can see is totally inaccessible. Okay. Gangster Daddy 510. I understand that we are receiving much weaker signals from distant spacecraft, but why are the data rates dramatically reduced? We talk louder, not slower, with increasing distance. Right. So the problem is signal to noise. So when you're very close and you are transmitting, then you are getting a lot of signal. And then the noise, the background radio traffic that is happening, the cosmic microwave background radiation, radio sources, pulsars, like there's a lot of radio signal out there. And the strength of your transmitter, as it gets weaker and weaker and weaker, as you get farther and farther away, as you said with the inverse square law, it gets harder and harder to distinguish between the transmitter and the signals that you're sending from your spacecraft and just the background. And so what they do is called error correction, where they will put a lot of additional information into making sure that the recipient actually is receiving the right data and they're actually getting the information. And that takes up bandwidth. And so you are still transmitting at the speed of light. You're still transmitting with the full bandwidth. But you experience this, right? Like when you go farther away from your Wi-Fi, you've noticed that your Wi-Fi speed goes down. That is because the signal is getting harder and harder for your computer to be able to pick that up and to be able to distinguish between the other radio sources that are around in your environment. And so error correction has to really kick in to be able to do that. Is there life on Earth? Have you rooted your sea star yet? Right. So last week, or maybe the last couple of weeks, I've talked about my project to root, to sort of be able to use my sea star with my computer and not with the app that runs on the phone. And the answer is yes and no. So I ran a demo a couple of days ago where I had Anton, who is in Europe, our producer. He was controlling the telescope and he was moving it around and he was looking around. It was daytime, so he was looking at trees and stuff. And it was really cool because he was, moving it around, autofocusing it, looking at stuff completely through his laptop, which is kind of the dream. But the functionality was very limited. I'm essentially able to open up the arm on the sea star, able to observe, get a live stream view that's coming from the telescope, be able to access, be able to look around. And so with that, I then tried to do a lot more sort of the actual practical thing that I want to do. Take the telescope, set it up, do the plate solving, get its GPS, and then locate an object and then track the object. And that has been really tricky. And I think I've sort of burned the whole project to the ground 4 times now. And so I'm working on try number 5. Actually, all day today I was working on this. And tonight's clear skies, so I suspect it's going to be a really late night tonight. So I'm going to try and get as much of it ready to go and operational and then try to get it going. But this has been totally using this really fantastic piece of software called SSC. I don't know what that stands for. C-Star something control. And so if you do a search for C-Star SSC, it's an open source project. It's in Python. You can download the repository from GitHub, get it running on your computer, and then you have control over the sea star and you don't need the app. It's really cool. But it does like too much stuff. And for me, if I was just taking pictures, I would totally use this piece of software only. It's really good. Lets you see the live view, lets you control the movement of the telescope, lets you take pictures, track things, take mosaics. It's really cool software. But for my purposes to do these telescope live streams where I can give a telescope to a person and say, hey, okay, now you take control of the telescope. I need to make something really simple. So I'm trying to make a wrapper that just uses a few of the functions that's in that software to be able to display in the kind of interface that I want. And that's been really hard. It's very complicated, either trying to use their existing interface or even to just try and access their API directly and to be able to make commands, or even get inspired by what they're doing to control the telescope directly and not even use that software, just, set up a connection to this, because I can connect to the telescope. I can make its arm open, but a lot of the other stuff is totally beyond me. So it's a fun project, a little frustrating, but I figure I'll get there eventually. WireGuard, you're saying WireGuard tail scale for remote access. I was using ngrok to just set up a way that a person could remotely access the service and then shut it off once I was done with it. So, I'll have to come up with a more long-term, like so many pieces, but that's what this summer is for, right? So I got a lot of pieces to try and figure out to bring it all together to make it work. But hopefully you will all see the results of this, that we will have 3 or 4 sea stars running simultaneously with fun people accessing them, maybe who've never used a telescope before, talking about space and astronomy and taking pictures. And hopefully then the simpler I make the process, the less sophisticated user that I can bring on board, right? And so you can imagine various, cool people who maybe don't have experience running telescopes, they can help, they can be part of the show. So that's the goal. And so, because up until this point, we've been dependent on the, either me doing a lot of the work, which is too high on my kind of cognitive load, or bringing on people who have good technical setups, but don't have a lot of experience being live streamers. So that's the challenge. So anyway, I'll keep you posted. Well, I guess I won't. I guess I will keep you posted. Like I'm going to go on live stream hiatus, but the second I figure this out, I will absolutely be doing live streams of this. So stay tuned. Rod Tolosa 4594. Will Vera Rubin detect alien spacecraft? Vera Rubin could detect alien spacecraft. It is probably the best chance to detect alien spacecraft. When you think about how much of a problem satellites are going to be for Vera Rubin, having it, that's because you're going to have spacecraft that are reflecting light, that are passing through the field of view, and it's going to be able to detect a lot of them. But also it can detect all of these asteroids, right? It's going to find 4 million asteroids during its 10-year operations. So if there are spacecraft that are moving through space around us and they are reflecting light or they are emitting light, and it is within the capability, the brightness that Vera Rubin is able to see, then it should theoretically be able to see them. So yeah, I think, if any kind of UFO or, alien space fleet here in the solar system was found, Vera Rubin would probably be the spacecraft that found them. Beyond that, it would then be probably Nancy Grace Roman. But yeah, Vera Rubin for the win. Bruce 5403. Does rooting void the warranty on your Sea Star? No, it has like a publicly available API that you can connect into it. So no, I'm not doing anything that's bad to the warranty. And even if it did, I don't care. Create a Bentation Funklogio, create a GitHub project to share your code, open source it, let us wayward, how to programmers offer help. So just go to the C Star SSC project. Like this is where it's all being done. I'm literally just adapting it slightly. So nothing I'm doing is very complicated yet. Richard G 1577. Is it just Richard G? Richard G. Vera Rubin found approximately 2,000 new asteroids in its first look, with over 1 million asteroids already known. How do astronomers track them all and ensure new discoveries aren't duplicates? Right. So they go to a place called the Minor Planet Center. And this is a website that's run by NASA. And whenever you discover new asteroids, you have to calculate the orbit of the asteroid. And so you have to watch them for multiple nights to be able to see how far away from the sun are they, what is their orbit. You can track an orbit, there's 6 variables that you use, and I forget what they all are, but they're like the eccentricity and the ascending node and the descending node and the there's like 6 factors. The distance to the semi-major axis. So you can take any object, and when you do enough observations of that object, you can calculate its orbit. And then once you've calculated its orbit and its current position, then you go and you register that. You do a check with the Minor Planet Center to see if that object is already in their database, and you can register it with the Minor Planet Center. And then other astronomers will do follow-on observations to double check the observations that you've made of that asteroid. So, even though space is really big and there are a lot of objects, that each individual object is going to have its own orbit, and that orbit is going to have, it's like a fingerprint. And so, every time you discover an object, you can just quickly calculate all the ephemeris, and then you can compare them against existing ephemeris, and then you will know which are new asteroids and which are already known asteroids. Mike Silver, does the orbital ratio of Pluto and Neptune make it impossible for them to collide, or do they really not cross paths? Yeah, it's the resonance that Pluto and Neptune are in, so they can't collide, that they're always going to be on this resonance. Is a 3-2 resonance? I forget the exact resonance, but they are locked in an orbital dance with each other, and so they won't collide. I can remember as a kid when Pluto was at its closest point. How old was I? Young. Austin App, if Planet 9 exists, is it possible that it would be geologically active, or would it be too cold? So it depends on the size. But the assumption is that Planet 9 is going to be big. Like, it's going to be Earth-sized big, or maybe even Neptune-sized big, but farther out. It's going to be a big object. And so if it is like Neptune-sized, then it's going to be like an ice giant. So it's going to be very similar to Uranus and Neptune, that it's going to have things that are like ices and volatiles. It's going to have like a rocky core surrounded by a slush of water ices and different kinds of volatiles, and then it's going to have an atmosphere that is like ammonia and methane. So it'll be like that. And so is that geologically active? No. But if it was a planet like the Earth, Earth-sized, then it would probably, it would be cooling down. It would still be very icy. It probably, wouldn't have a lot of rock inside of it. And so whatever it was, it would be like a very large Enceladus or a very large Europa. And, it wouldn't be in orbit around something. So it wouldn't have the same tidal activity. But chances are, if it's that big, then it's still going to have some residual heat internally from its formation, from whatever radioactive decay is going on internally. And so that is probably going to make its way out to the surface in some way. So you could see cracks on the surface. You could see places where there's cryovolcanism on the surface. And it's kind of amazing how active even Pluto is. Pluto has glaciers of the kinds of things that you would consider to be atmosphere around other worlds, and yet Pluto has them just move around its surface as glaciers. So, I think once we actually find it, it's going to be really exciting. Like I realize that I don't really spend a lot of time thinking, kind of imagining what Planet 9 would be. What would it be like? And I think as Vera Rubin is coming online, and that's going to be one of the objects that it hopefully will find, that now we start to wonder, like, what is this thing going to look like? How would we study? Will we send a spacecraft out to do a flyby of it? It's pretty exciting times. Busy Billy B33. If you had a giant neutrino detector pointed at Jupiter, could you detect neutrinos coming from its other side? Sure. Yeah. Yeah. Remember, neutrinos can go through a light year of lead. So passing through Jupiter, no problem. So if you had, some secret alien neutrino factory on the far side of Jupiter, and we had a neutrino telescope that was pointing at Jupiter, we could detect it. Red Streak 1, Fraser, if Pluto was reinstituted as a planet, it would only be fair to make Eris one too. Well, this is the problem, right? And this is I think when people are like, oh, it really bums me out that Pluto isn't a planet anymore. It really should be a planet. That the whole reason we had this controversy about Pluto being a planet or not was because of the discovery of Eris. That you've had another object that is roughly the size of Pluto. Like when they first found it, maybe bigger than Pluto. That is a little farther out. And so what do? Right? You can't say, well, there are 9 planets in the solar system. There's Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto, and then this other object that is bigger than Pluto, but we don't call it a planet. No, there's 10 planets, right? Eris 2. So you can never just say there's only 9 planets. Now there's 10. Okay, what about Haumea? What about Makemake? What about Ceres? Okay, now you've got 12. Oh, now you've got 15. There's 15 planets in the solar system. If Pluto is a planet, then all of this other stuff are planets too. What about Ganymede? It's bigger than Pluto. Doesn't it get to be a planet? What about Titan? Are they planets? So, you could make the argument that there are, and people have, that there are more than 100 objects that are essentially planets in the solar system. Things that have been formed into spheres through hydrostatic equilibrium, that the gravity is pulling them into a sphere and they're not remaining in this weird shape. Spheres. So I think, and anybody who wrestles with this challenge, is anything that has pulled itself into hydrostatic equilibrium and is not orbiting a planet considered a planet? Fine. That sounds great. But don't complain when your kids come home and they are grumpy because they have to remember the 18 planets in the solar system. They're going to be mad, right? Or you go this route and you just say, those are the planets and these are the things that are not planets and that we have 8 planets in the solar system. I don't care. I just don't care. Some people are really mad about this and very resentful, and I will get emails. And I just, I think each object is important and special and should be considered for its own unique characteristics, and I don't really care. And so if people tell me that Pluto's a planet, I'm like, great, Pluto's a planet. People tell me, if the International Astronomical, if the IAU, the International Astronomical Union, changes its mind and says, no, Pluto's no longer a planet, I'm like, fine, I don't care, right? It's Pluto. That's what matters. So, yeah, I don't think and so I think if we're going to get a lot more, Vera Rubin could very well find 20 objects in the outer solar system that are as big as Pluto. Are they planets? When does this stop? So you decide. I'm not going to. I'm out. Casey Ream, would we be able... No, Casey Ream, would we... Casey Ream, would we be able to launch a mission to Planet 9? Sure, absolutely. We could launch a mission to Oumuamua, which is an interstellar object that is zipping out of the solar system on an interstellar trajectory, and it's not coming back. We could chase that object down if we had the will. Flying out to Planet 9, let's say it's 200 astronomical units away, 500 astronomical units away, we could build a spacecraft that could do that. And in fact, it's the same kind of challenge that we would need to do to be able to go out to the solar gravitational lens, which is at 550 astronomical units. So what if we launched a mission that we found a planet, when we find Planet 9, then we find a extrasolar planet that's on the other side of the sun from where Planet 9 is going to be when our spacecraft gets out there. And then we send the Solar Gravitational Lens Observatory out, it does a flyby of Planet 9, and then turns back and uses the solar gravitational lens to observe a distant exoplanet. That'd be a twofer. So yeah, absolutely. It's just requires new kinds of propulsion technology, requires budget funding, and requires the will over multiple administrations or multiple countries working together to be able to pull this off. But it won't be cheap. It'll be expensive. But you look at something like, say, New Horizons. New Horizons was a relatively inexpensive mission compared to larger flagship missions. And in 10 years, it got all the way out to Pluto and to give us the first close-up images of Pluto, and then took pictures of another Kuiper Belt object. So these things are possible. It's just, we're canceling. Right now, NASA is having to cancel the Mars sample return mission, which is like the top priority of the scientific community. That's getting canceled. So going out and visiting Planet 9 is lower. Like, we haven't gone back to Uranus or Neptune. So there's a long list of things to do before someone says, okay, let's send a mission out to Planet 9. But I guarantee the moment Planet 9 is discovered, somebody is going to start figuring out what a mission to Planet 9 would look like. I'll bet you there's even a paper right now. Like, we just covered a paper on Universe Today about sending a mission to Sedna, which is pretty far away, would require like some kind of direct fusion drive or a solar sail, with some kind of, close maneuver past the sun. So, there's a lot of targets that are out deep in the solar system that are worth going to and would challenge our current ability to send missions out that far. And we should do them because doing difficult things is worth doing, because it makes us better. It makes us more advanced, more capable, better able to deal with the rest of the universe. So I think we should be preparing for a mission to Planet 9 right now, and then we just send it to Uranus or Neptune or Sedna if our plans change or if we fail to find it. Dougal, how often do you perform your own thought experiments? Never. That's a weird question to me. Yeah, I mean, like, if I'm trying to figure something out, I will sit down and think through it very deeply. Or often I will, I'll be thinking through things I'm often rattling problems around in my head, and often will come up with the answer when I'm on a walk or, in the shower, right? But like actual thought experiments to try and understand physics concepts, I'm not a physicist. I'm a journalist. I'm not a scientist. And so I know that the kinds of scientific questions or the answers to the scientific questions are not within my capability currently. They're just, that the kinds of tools or the kinds of thought experiments that I would go into to try and solve a problem would be laughably simplistic to anybody who actually knows what they're talking about. And they would just go like, obviously we've all thought of that, Fraser, so don't bother. Now, the closest I get to this is when I'm interviewing people, and they will be explaining a situation, and I will have some knowledge because I've interviewed somebody else that's over working on something that's kind of related, and I'll be able to connect some dots in a way that seems novel or fresh to the person that I'm actually interviewing. And they're like, oh, that's a good idea. I never thought of that. Like, great. But nobody has ever told me, oh, we wrote a paper, we included you as a co-author because you came up with that idea during our interview. That's never happened. So, and I'm not expecting it ever will happen. But I wonder, is that a thing that I don't do? Are a lot of you doing your own thought experiment, like Einstein style thought experiments where you're like, I wonder what would happen if I was on a spaceship and I fired a beam of light out into space? Edward Slug, is studying the universe the only scientific subject with no final answer? Oh, that's a really good question. It's a very philosophical question, which is like if you had a whole bunch of questions about the universe, right? Where did the universe come from? What is its ultimate fate? Why, why is there something and not nothing? Why are the variables? Why are the various constants in the universe what they are? Could they be something different? Are there other universes? Is this inevitably what the universe must become? Or are there other possibilities? What is dark matter? What is dark energy? Why was there more matter than antimatter at the beginning of the universe? What came before the universe? Like there's a ton of these really deep questions. And, are we living in a simulation, right? And so even if you could make progress on all of them, like if you could go, like, we know what dark matter is, we know what dark energy is, we know why there's more matter than antimatter, we know what came before the universe, right? The proto-universe, this other thing, it just kicks the question back. And you just got to ask yourself again, okay, then what came before that universe? Like what, was that always destined to happen? Like what were the conditions? And it's even harder to research it because now it's one step removed. And every other scientific question is a subset of that, right? Chemistry is a version of physics. Biology is a version of chemistry. Mathematics is a way of describing things, but physics, cosmology, physics really is sort of the base level of reality. And so you'll never have a satisfying full understanding of everything because you're always kicking that question down the road. And it's the same, like whenever someone posits a theological answer to the, to some of those questions that I just asked, the problem, of course, is that you just kick that can down the road, right? Where did the universe come from? God made it. Okay, where did God come from? I don't know, right? Just made himself. Well, okay, that seems like a problem. So no matter what, I think philosophically, we will never get to the end. We will always have more questions. And what you find with every new paper or every new mission that gets launched that's designed to answer the questions that we had before, we now have new questions, right? We're having questions about we're having questions about little red dots. This was an object discovered by James Webb, and so we didn't know what they were. We have questions about fast radio bursts. We have questions about magnetars, right? All of these weird things that are out there, we didn't know that we had questions about them until they were first discovered. Jumbos, right? How can there be two Jupiter mass objects orbiting around each other? That's weird. So yeah, this process will never end. But that's what makes it fun, I think. It would suck if the mystery had to come to an end and they had to have a final season or like a final episode of understanding the universe. So no, I don't think, man, such a great question. Yeah. Fred Jonestown's, how long until we reach Enceladus? Oh, a while. So back at the last decadal survey in 2020, the scientific community came together and they posted their priorities. Number 1 priority, Mars sample return mission. Number 2 priority, mission to Uranus or Neptune. Number 3 priority, a mission to Enceladus. Ideally, some kind of lander, the Enceladus orbital lander. And, we're not going to get the Mars sample return mission, we're not going to get the Uranus mission, and we're not going to get the Enceladus mission this time around. Who knows? Maybe when the astronomical community comes back together for the decadal survey in 2030, and they will say the same priorities because they haven't been met yet, then maybe the, NASA and other space agencies will be in a better place to be able to do it. That said, I am reporting nonstop on potential mission ideas to Enceladus. Like if you go to Universe Today, which you should, I am, anytime I see somebody proposing an idea for going to Enceladus, we will run a story about it. And I've done several interviews here on the channel about it. So, if you're interested, people have really good ideas about how we could explore Enceladus, land near the geysers, to be able to sample them directly, hoppers that could jump through the geyser to be able to sample them. Really cool solar sails that could get you out to Enceladus very quickly. There's a lot of really good ideas. Sampling and calculating your results while you're out there or doing a sample return and bringing them home. They're great ideas. Enceladus, and that's what our whole channel is about. That's what Universe Today is all about, is this kind of thing. And every time I see anyone just put their neck out and propose an idea for sending a mission to Enceladus, I am all over it. But realistically, we've got to know that it's going to take us a long time before this actually happens. I would say in the 2040s, maybe the 2050s. Buddha fan, have you seen the Project Hail Mary trailer? Like 3 times I have seen the Project Hail Mary trailer. So for those of you who don't know, and I should actually make that my outro in the question show that I record. Mental note. Okay. Which is the Project Hail Mary trailer. Man, it looks so good. Like, it both looks well made and seems to have a lot of the humor and style of Andy Weir, but also captures the stuff that happened in the book quite accurately. And in fact, they kind of spoiled it. I couldn't believe, when you read the book, a lot of this stuff just unfolds where you don't know what's going on, and you get these flashbacks where you find out more and more what's going on. And they just told the whole story in the trailer. It's kind of crazy. So yeah, we'll see. Man, but it's really good. My favorite part of this is where they're like pointing at this, every star has been infected in this large area except for this one. And so he asks, like, why not? And then she like points to all the scientists in the room, like, we don't know. It was so good. Anyway, yeah, it looks great. I'm so excited. March 26th, 2026, which is forever. I have to count how many sleeps that is until we can watch that movie. Gangster Daddy, besides the first 10 hours, what has Vera Rubin discovered lately? What has Vera Rubin done for us lately? So all we saw were the commissioning images. So they're putting Vera Rubin through its tests right now. And so it's not in its full science operations. So the asteroid test, the galaxy test, the nebula test, they've completed that. And those are examples where, like, what would it look like if you accumulated hundreds and hundreds of images of Vera Rubin of one specific object, which is what they will later on be doing, but they'll be doing it, night after night after night over the course of 10 years. They just compress that down into one session. And same thing for the asteroid. So they're in the process of this commissioning phase. And so we're not going to go into the full run until later on this year. So stay tuned for that. Are there plans for a telescope equivalent to the Vera Rubin Observatory for observations from somewhere in the northern hemisphere, like the Canary Islands or Hawaii? Now, I asked the director of Vera Rubin, Dr. Edward Ajar, this very exact question. And, the answer is the obvious one, which is like, it would be awesome to have another version of Vera Rubin in the northern hemisphere. But the challenge is you only have budget for one. It was $1 billion. They only could make one, so they made it. And the best place to put it was the southern hemisphere. So that's where they put it. And that'll get you about 70% of the sky. So you're still missing about 30% of the sky that you just can't see from that part of Chile. And would it be great to have a version of it in the north? Absolutely. There are lots of telescopes that, I think about the Gemini North and South. So the Gemini North is in Hawaii, the Gemini South is in Chile, and the two work together to look at various objects, and sort of, we have these twin telescopes. And you could imagine a version of Vera Rubin in the north that's doing the exact same thing, and it's completing that observation of the sky. Where would you put it? Yeah, you put it in Hawaii, which would be ideal, but obviously, we've seen a lot of challenges to putting large observatories in Hawaii. So your second best place is the Canary Islands, and it's still pretty good. It's not quite as good as Hawaii, but it will do. And so that's the Canary Islanders are super ecstatic to have a big observatory installed. So I think that's the place you're going to see this is, you're going to see probably the 30-meter telescope go to the Grand Canary Islands if it ever gets built. And you're probably going to see the Vera Rubin North go to the Canary Islands. But there's a lot of learning that needs to be done. And so the whole point of building the first Vera Rubin, you had to build the big telescope, build the big mirror, get all of the operations working, make sure it all works. And then you learn all of your lessons, and then you build the next version, and that will be the partner in the north. But, wait for another maybe 10 years and they'll start building that version, or never. Who knows? Depends on how much funding there is for science. B-dubs. Are there any other known objects that closely resemble Oumuamua in shape and size? No, not really. Oumuamua is pretty bizarre. It has like a 10-to-1 length to width ratio. So it's, they described it as like cigar shaped. It is sort of, or cylindrical shaped, or rendezvous with Rama shaped. But it is a long object. Now, there have been plenty of explanations for why you could have something like that. Like there was a cloud of liquid hydrogen that was ejected out of a solar system, and it was spinning, and the particles froze into this long shape. There are explanations that can explain it. Obviously, there are people who think that it could be an example of some intelligent civilization's interstellar probe. That seems far-fetched, but you can't rule it out until we actually send that mission to chase it down. But no, it is not the kind of shape that we see for stuff here in the solar system. And does it mean that other solar systems are producing objects that are different shapes? Or is it just that we just haven't sampled enough objects here in the solar system, and that once we see more comets coming from the Oort cloud, this is going to feel like a much more common object? I feel like I'm a broken record, but the thing that's going to help us is Vera Rubin. So it is exquisitely designed to find interstellar objects. And so while we know of 2 so far, we will probably learn of dozens every year thanks to Vera Rubin. And by the end, it's going to be hundreds. And some of these will be really good targets for us to send missions to. And so you can imagine, right now, the European Space Agency is considering a spacecraft called the Comet Interceptor. And this could also be an interstellar interceptor. So something that would go out to the L2 Lagrange point, loiter around, wait for a target, and then when either a long period comet is coming in from the Oort cloud or an interstellar object has been discovered, then it will kick on its engines and go and intercept the object, take pictures up close, which I think is a really cool idea. And so we could, Vera Rubin could turn up another object that has similar characteristics to Oumuamua. I think people don't realize how little of the sky is being observed on a regular basis the way Vera Rubin is going to do this. It is an entirely new window into the universe that is about to come operational. And that's why I like the coverage. Watching the coverage of Vera Rubin was very frustrating to me, for the mainstream media, because people just didn't get the point. This great new, big new observatory. Look at these pretty pictures. It's really cool. It's the best. It's the biggest camera ever made. Now on to the weather, right? I'm like, no, you don't get it. This is what, this is the television versus print. This is a totally new paradigm, a new revolution in astronomy, and it's going to change everything. But it's fine. I'll do my job. I'll report it. You'll see. You'll all see. Any Alexander, will Fraser ever tell us his favorite Lagrange point? We all know he has one. It's probably the Earth Moon L4 point. If I had a favorite, it'd probably be that one. Oh, you want to know why? It's a stable point, a place you could put a space station. You think back to the Gerard O'Neill, the L5 Society. L5 would be fine as well. These are these places where you could put a large rotating space station. I'm still all in on giant rotating space stations as the future of humanity in space, not colonizing Mars, living in space. But you need some kind of artificial gravity. gravity wells are for suckers. So yeah. And in order to really make that work, you want to go to the L4, L5 Lagrange points. So either L4 or L5, either will do. Those are my favorites. Done. Okay. Gravity wells are suckers. All right. Wink demand. When do you think we'll finally find aliens? I have no idea, but I think we should search. So, you know, but it's possible we will never find aliens, but we can't say they're not out there until we've really tried hard. So we need to explore Mars, looking for evidence of life. We need to go under the ice on Enceladus. We need to set up radio telescopes to listen to signals from other civilizations. We need to use every technique we can think of to examine the universe, both at the small scale, looking at individual stars, planets, looking for megastructures, trying to detect chlorofluorocarbons in the atmospheres of other planets, to looking for Dyson spheres around in the Milky Way, to looking for civilizations that have conquered their entire galaxy, you know, type 3 civilizations. So we should be looking at every level in all directions all the time for as long as we can. And we will never know if we're truly alone in the universe, but we have to sort of check first. I think a lot of people, they just assume that the aliens are everywhere. So why bother looking? Which is crazy to me, right? Like you can't just assume you know the answer to this question. You have to find out. You know, the classic thing, I don't know if this is an apocryphal story, right? Where a bunch of philosophers were arguing about how many teeth a horse had. And somebody says, well, just give me a second. I'll just go count. And all the philosophers laughed at them, right? Like, why would you count? You know, you don't count the horse's teeth. This is a philosophical question that we need to reason about right here in this room. You know, so we don't know if there's aliens out there. We just have to find out, or continue to fail to find out. But we have to keep trying. Nigel Dawson, how do they keep these massive telescope lenses clean, or does that affect the images too much? So we learned about this with Vera Rubin and all the other telescope facilities, is that they have a facility to resurface the telescopes. So over time, the telescopes do get a layer of dust. They get, you know, little bits of just, I don't know, like soot and dust gets onto the telescope lens, and they can repolish it. But what they can also do is resurface it, recoat it. So they take the telescope, they actually have a facility right where Vera Rubin is, and they can unmount the entire primary, tertiary mirror, take it into this facility, polish up all of the material on it, and then put a new silver surface back onto it, and then bring that back out and put it back up. And so whenever they're watching the optical quality of the telescope all the time, and whenever it drops below some certain amount, they will fix it and resurface it and then bring it back out. And this kind of facility is available to all of the large telescopes. WJXS8XJ. Would you view the discovery of alien life as bad news? No. I would love to know if we discover that there's other alien life out there, and that there is a vibrant community, a foundation, a federation, the empire, That would be scary, but it would also be like, obviously they can work together. Like obviously they can cooperate. And so we can show up and hopefully be taken seriously. But if the thing that we discover is this expanding sphere of planets and stars that are being turned into Dyson spheres, and this thing is expanding at, say, half the speed of light, it's coming our way. And we know that in about 1,000 years, this thing is going to cross the solar system. That is definitely unnerving, especially if they don't send messages out. They're not communicating. They're not telling us that they're there. That is a bad sign. And that it's just a matter of time before the Vogon constructor fleet shows up and tears apart the solar system and moves on. That's scary. But, if we receive alien signals and they're trying to communicate with us, then that's all good. So really, it just depends on how they behave and whether it's a good sign or a bad sign. Rick W141, will we get to Titan and fly that chopper? Yes. Under the, I didn't mention, so we recorded Astronomy Cast today. I forgot to mention that. But yeah, under the new budget cuts to NASA, the Titan Dragonfly mission is still going to go ahead. So Nancy Grace Roman and the Titan Dragonfly are still moving ahead. Other missions have been canceled. Ascani21. If dust gets on the lens of a space telescope, how much dust would be a problem for a super fast spacecraft? Would dust render interstellar travel impossible? So this is one of the questions that people have absolutely had about interstellar travel, that if you were traveling in between the stars and you were going to travel at relativistic speed, say 20% the speed of light, then you are going to be bumping into the stuff that is in between space. And there's not a lot of stuff. It is a ludicrously empty vacuum. And you could count, a few hundred particles of, protons per cubic meter. Like there's not a lot of stuff out there. But there is some stuff, and there are definitely particles of dust. The question is, we don't know how many there are. Nobody has ever done this survey. We know there's a lot of dust here in the solar system, especially a lot of dust orbiting around the Earth, but that's to be expected because there's a lot of asteroids crashing into each other. There's space junk. There's all kinds of stuff. And so one of the big questions right now that people don't know the answer to is like just how much dust is out there. But it's not as terrible as you would think that it would be. So, if you had a single grain of sand strike a spacecraft, it would do damage. And so you would want to have some kind of shield in front of you, like a physical shield, like a plate of metal. But it doesn't have to be a lot. Like a few centimeters of aluminum is probably enough to protect your spacecraft from small particles of dust, things that are in the, the microns across. Larger pieces of dust or even little asteroids, yeah, you could be hitting yourself with a bomb, and you just have to hope that it doesn't hit. And so the current ideas for interstellar spacecraft, that they will probably have some kind of ablative shield in the front of the spacecraft that will, that's going to take the guaranteed ions that are going to be hitting it. But that's more like actually probably won't reduce it more than a few millimeters, and they can handle the occasional piece of dust that could be out there. And we don't know how many, the ratio, how many of them are out there. But the way you solve this problem is you send a lot of spacecraft. So like Breakthrough Starshot is planning on sending thousands, tens of thousands of tiny little, or I guess 10 meter across solar sails that weigh a couple of grams, and just send them one after the other. And some are going to get destroyed in transit. Some are going to go offline. Some are going to break down. But as long as some make it there, then we will be able to get the data from Alpha Centauri or Proxima Centauri or whatever. How do we have multiple people have number 1? Weird. I hate this number 1 system. The top fans. Do I turn this off? No. Bummer. Owen Bowen, if you had a small planet, could you make gravity by creating a tiny black hole? Like, I'm not sure why you need a small planet. So if you took the Earth and you turned it into a black hole, then it would only be, I think, a centimeter across. Like, it wouldn't have to be very big. And then you would have all of the mass of the Earth in an object that was about a centimeter across. Maybe it's 4 centimeters across. Anyway, it's very small. And then you could, like, then what? Then what's your plan, right? You've got a thing that you can't touch because it will just gobble up your fingers. You can't shoot light at it. You can't shoot lasers. You can't move it. The only way that you can really work with this black hole is with gravity, that you have to set it up into some kind of gravitational interaction with something else, like Jupiter, or maybe a black hole with the mass of Jupiter. But you're going to try and live on it. You're going to try and construct some kind of sphere around it to live on. What's going to stop it from just drifting through the side of your sphere and gobbling that up and then dismantling the whole thing? So the problem is that working with a black hole is very tricky, and you have to be very careful. How do I even turn it off? Can I turn it off? Nope. No, they won't let me turn it off. I'm sure there's a way to turn it off, but it doesn't work. Yeah, why did they inflict it on me? Sorry, just looking at the questions. Serenity. Will our future be more like Star Trek or The Expanse? It all depends on what's going to happen with artificial intelligence and the singularity. So if our technology continues faster and faster, and the artificial intelligence gets more powerful, and we get this kind of intelligence explosion, and things go vertical, and we don't really understand what the future holds beyond that you would say that the future looks more like the Borg, where computers are expanding outward into the universe at, just shy of the speed of light, gobbling up every star system and galaxy that they can get their hands on. That they're trying to take control of the universe. That's one possibility. Another possibility is that there's some reason why artificial intelligence will fail. That the human brain is the most intelligent thing that can possibly exist in the universe. He says, sarcastically, skeptically. No, I think there's a lot more capability for intelligence above human beings. In the way there's a lot more capability for playing chess than what the best human being chess player can do. So it's really hard to predict a future of the universe when you are trying to figure out what the future of technology is going to look like. And it's going to happen very quickly. Like, it's going to happen in the next 10 years. We will see a lot of the impact of all of the increased technology that's all around us right now. Data centers are going to get bigger, the AI is going to get faster, and it's going to start to run more and more of our life. And so then the question is, what do we do with that, right? Are we going to just give in to letting the AI, I don't know, work on our college assignments, clean our houses for us, do the difficult and complicated work, create all the entertainment for us, maybe. Or are we going to decide, like some kind of, I don't know, techno Amish solar punk future where we decide like that's enough, like okay, like we've got technology making sure that we don't get sick and that we've solved war and malnutrition and all this kind of stuff, but we still need some kind of human meaning. And then what does our technology look like? Now, my favorite version of this is in The Culture, which is the book series by Ian M. Banks. And he imagines this future that's mostly run by artificial intelligence, right? They're the ones really running the show. There are giant planet-sized ships. There are orbital space stations, kind of like, ring worlds from Larry Niven. And they are doing things. They are thinking deeply. They are doing scientific experiments, and they are peacefully interacting with the biologicals that live within their, which are part of this larger society. And then The Culture, it's a post-scarcity civilization. And what does that look like? Right? What do you do with your day when you no longer have to worry about work, where you can change your body any way you want? You can have access to every kind of drug, every kind of experience. Any idea that you have, you can bring that forward and implement it in the real world. Like, it's a weird place. And yet, at the end of the day, we need to be able to get along. We need to not ruin each other's rights. We need to be able to accept the diversity of other people, of what they want, as long as it doesn't hurt anybody, right? Sort of the ultimate libertarian world that also isn't inflicting itself on other people, which, seems to sort of missing from a lot of libertarian philosophy. So, but that's my favorite, is The Culture. And I think that's the future. When I can think of all of the horrible futures that everything could come out to, that's the one that's like the least horrible to me. But yeah, like Star Trek is just naval warfare in space. And The Expanse is a much more realistic version of that. But, they're using a totally invented engine system, right? The Epstein drive, something that can take you very efficiently, carry you across the solar system. And, we have no reason to believe that that's going to be the case. So I think it's really hard. Like, I can't think of any science fiction that has accurately wrestled with the kinds of futures that we face on the technological track that we're on right now. And I don't think you can. Like, I think the whole point of the singularity, technological singularity, is you don't know what's on the other side of it. You don't know what happens when our computers are advancing at an exponential rate and things get weird. And so not, it's the 1960s, but now you're in space, which is what started. Like, go back and watch Star Trek. Go watch the old show again. And you'll be like, ooh, this is dated. So, yeah. Yeah, I don't know. I think we live in a really funny time. And we're going to find out if it's going to get really weird in the next couple of years, or we're going to reach some kind of fundamental level and things are going to just dial back down and things are going to get normal again, right? Either AI is real, and I like a lot of you are experiencing it. You work with AI, you write code with AI. I do it all the time, right? I don't let it write though. I don't let it write my stories. And I'm sick of the pictures and I'm sick of the video, but I'm very interested in using it for code. But what if it can keep doing other stuff? Where do we let that stop? So neither Star Trek nor The Expanse, the outcome that I'm hoping for is The Culture. Rob Hawk, Soiling Green, now with more people. That's funny. William Hallman, what's your take on the UAP phenomenon and its history in the US and around the world? You have never talked about that, and it's super related to the entire industry and your career. Thanks for your feedback. So I talk about it all the time, which is that there is insufficient evidence to have any opinion. So some people are make allegations that they have seen things, and yet the people who study those kinds of things have not been provided the evidence that they require to be able to make any further progress, right? Imagine if your friend said, I saw something really amazing. It was a dinosaur. I saw a green dinosaur walking down the street, and your friend is a paleontologist, and he goes like, whoa, that's amazing. Where is it? Let's go check it out. And you're like, I don't remember where it was. Some street, it's gone now. And so now, like, your friend, your paleontologist friend cannot help you, cannot study this thing because it is nowhere to be found. And so this is the problem that we have with UAPs. People are making allegations. People are saying they see things, but no useful evidence is being supplied to scientists who study materials, who study astrobiology, who think about these kinds of issues day and night. And so until that happens, it will all have to remain in the area of unexplained, unidentified. And so it's right there in the name, unidentified aerial phenomena. Unidentified. We don't know what they are. And I think, many people say it's unidentified, therefore aliens. And that's a jump too far. You can't say unidentified, therefore aliens. You have to say unidentified and then just stop there. What is it? I don't know. When will we find out? I don't know. Who's got the evidence? I don't know. Right? That's it. That's where we are. So, and anyone who tells you that they know otherwise, I think you should be very skeptical. You should be very, very cautious to listen to anybody who's telling you that they know what this is, when the people who have studied these kinds of phenomena, materials, atmospheric stuff, space, astronomy, astrobiology, have not been given the evidence to be able to study it in the way that science works. So for now, what's my take? I am unconvinced that anything is actually happening. I am very skeptical, and I am assuming, because it's been decades, that people have been promising to deliver evidence and they haven't done it, that will continue on for decades more, probably forever. That, if we find evidence of aliens, it's not going to be because there was disclosure that the US government was hiding it. It's because someone hooked up a brand new telescope that was allowed us to observe the atmosphere of another world and detect the presence of chlorofluorocarbons in that. Or we detected the signal coming from an alien civilization. Or we found evidence of a Dyson sphere orbiting around some other star. Or we detected an entire galaxy that had been turned into Dyson spheres. That's going to be the evidence that I would find a lot more convincing than what's been found so far by the UAP community. But I remain open-minded. I can't wait. People are like, oh, you're so close-minded. No, I'm open-minded. I can't wait to be wrong. Prove me wrong. Bring it. Like with actual, and like, don't tell me, like, take the evidence to a scientist who is specialized in that thing, and then have them write a peer-reviewed journal article about the thing that they are studying, that the rest of the scientific community can then study and question whether or not it's true. That is how you bring it, as for me as a science journalist. Yeah, Mick West. So people talk about Mick West. Mick West did a great one recently where, people from some TV show that I've never heard, Skinwalker Ranch or something, where they posted some weird wiggling light in the sky, and they found the exact plane and confirmed the exact trajectory that the plane was taking. This kind of thing, with enough research, they almost always have, like 99% of them have perfectly rational explanations. The ones that remain is that there just isn't enough data to come up with a rational explanation yet. But if we had more data, then we would know. Jedward, what are the impediments to creating a photovoltaic battery system that would survive the lunar night? Is anyone working on this? Yeah, this is a big problem, obviously, that a spacecraft that goes to the moon, if it's done on the cheap, then you don't have money for plutonium, for an RTG to install on your spacecraft, then as soon as you get to lunar night, then temperatures are going to dip by, what is it? It's like 170 in the daytime and then negative 100. Like it's ridiculous, the temperature extreme that a spacecraft on the surface of the moon has to go through. And then you spend 2 weeks in this deep freeze, and no amount of stored heat, no amount of stored electricity is going to keep your batteries warm. And eventually the batteries are going to get below freezing and they're going to die. And this is what kills all these spacecraft. Now, you can put a smaller piece of plutonium into your spacecraft. Its only job is to keep your battery warm. And this was done with the Mars spacecraft. And I don't know what the Chang'e 5. So one of the Chinese landers has been lasting for month after month after month. So, there are a bunch of strategies that people have proposed. A lot of them involve plutonium or other isotopes, americium, strontium. But the other possibility, and this is an idea that I really like, is using the regolith as a heat battery. So there are technologies that people are testing out in Finland where it's called a sand battery. So they just take pipes, they put them into the sand, they run hot water through the pipe when the sun is shining, and then the sand stores the heat throughout the winter, and they still have hot water coming out of the sand well into the coldest times of the year. And it's a really clever technology, like dead simple, like a cylinder of sand so you can imagine a spacecraft landing, and then maybe it would put some kind of, maybe it would drill some kind of temperature probe down into the regolith, and then it would somehow warm up while the sun is shining. It would be warming up the regolith underneath it, and then it would be able to extract that heat back out. And we reported on this on Universe Today a couple of years ago. Somebody had sort of done the math for how big of a mass of regolith you would need to be able to store the heat of the sun so that you could then extract it again. So fission reactors, RTGs, or some way of storing heat in the sand or in the regolith is going to be the way. Dougal, will the Patreon question show continue during hiatus? Absolutely. Frosty Winnipeg, wouldn't Dyson spheres get hit by comets? Yeah. Then you send another, I mean, it's a Dyson swarm, so it's a bunch of spacecraft. And so it's, one possibility is you've gone out all the way out into the Oort cloud and you've extracted every single object in the Oort cloud to use for your Dyson sphere, your Dyson swarm. The other possibility is that you just repair the individual satellite when it gets hit by a comet. Remember, it's not a rigid sphere. It's a cloud of satellites that are gathering all of the light from their star. RJQ, why is Eris's albedo so extremely high? Covered in ice. LD Soch, if you could, in the future, you could carry your soul and memories, but only in a robot, what kind of robotic body would you want to have? I make that joke all the time that, I'm going to live forever because I'm going to get my robot body. The challenge is, can you switch to a robot body without being destroyed, right? Because if you have to die for you to then have your memories implanted into a robot body, then your consciousness doesn't continue on. It's kind of like, getting into a transporter. Like if it dissolves you and then recreates a copy of you somewhere else, you died. And so the same thing, right? If you get a robot body, there needs to be a way that you can very carefully transition, like the ship of Theseus, transition your neurons from organic to silicon. So as long as that's how it's done, that I get to continue my consciousness. What kind of robot body? Well, then it doesn't matter, right? You pick the robot body that is most appropriate for the task at hand. If you want to be a spacecraft, then your robot body is a spacecraft. If you want to be some kind of robot on a, that's walking around on the surface, then that's a different kind of body. So, we would be able to have robotic bodies that would match the mission that we have for them. Hammerfan, let's assume we could find clear evidence of an advanced alien civilization with our telescopes. How do you think it's going to influence our society from there on, and how would it influence your job? So I think like a lot of people think that we found evidence of an alien civilization out there in the universe, that it would destroy human society, that we would freak out, we would lose our minds, religions would be destroyed, that it would just be chaos on Earth. And I don't think so. I think that humanity's capacity to absorb new knowledge and then just carry on like nothing has happened is bottomless. And so I think, in the beginning, yeah, I would be reporting on every attempt to understand. Like my job would never end at that point, because we would be reporting on all of the spacecraft, all of the observations, all the new telescopes that are being developed to try and analyze this, all of the messages we're sending, the messages we're receiving, what we've learned so far. Now that we've got a way of understanding, what have we learned more about? This would go on forever, right? But I think regular people would be like, oh yeah, I remember when they discovered aliens. That was pretty weird. But now I'm just going to go about my regular life and get on with my job and live my life. And so I think when you think about the kinds of either incredibly good events or traumatic events that we can live through and just sort of reset to our new normal, finding evidence of aliens out there in the cosmos we would be back to normal within some very short period of time. It would be big news, and then it wouldn't. And then it would just be, normal news from that point on. Yeah. It's kind of, I always like, we're just so capable of turning everything into this kind of bland outcome. Larry Leak, once the energy is collected by a Dyson swarm, how would it be distributed or utilized? Locally. So, the idea of a Dyson sphere is not accurate. It's a Dyson swarm. So it's going to be satellites, habitats, various specialized things that are orbiting around the star. And each one is going to be collecting energy. And then it might be that maybe they're running a data center on that spacecraft. It's collecting a bunch of energy, and then it has a big computer that is running ancestor simulation, or it is a factory for producing metamaterials. It's pumping out spacecraft. People live on it. Who knows? But chances are it's going to be used just locally by whatever is the satellite. There are possibilities that they will beam the power somewhere else. So you may have a whole bunch of just solar collecting satellites, and then they are beaming their light to some other object that is either farther out away from the sphere, or maybe it's closer into the sphere. Although you're kind of turning it into an oven. There's like a challenge of the fact that if you do trap the radiation coming from the star, it does heat up the temperatures inside the Dyson sphere. And it happens even all the way to like a Dyson sphere the size of Uranus, the orbit of Uranus, that you would still get a lot of heat building up inside the Dyson sphere. But yeah, you just use it locally for whatever you need it for. Probably computing. Scanning 21, is Rick and Morty a valid documentary about the multiverse, or is it slightly exaggerated? Totally accurate. John Raznick 195. What do you think about the possibility of caverns in the moon being used for moon bases? I think it's a great idea. You know, there are not a lot of places on the moon where you can get some kind of relief from that temperature shift, the hot, cold, hot, cold, hot, cold. But you can in the permanently, you know, in the collapsed lava tubes on the moon. So you've got these places where there was once lava flowing, and then it emptied out in this giant chamber. And these things can be big. Like they can be 10 kilometers tall. And then you've got like the roof collapsed a little bit. So you've got this skylight at the top. But if you set up down at the bottom of this lava tube, then you are protected from the radiation from space. You don't need to build radiation shielding. You have some protection over the temperature back and forth. I mean, you're in the shade, so it's cold, but you can put some kind of solar panels outside, or you can, you know, we talked about this earlier on, you can try to use some kind of regolith battery to heat up the regolith around you and keep the place warm. So they're the most interesting places. And again, I've done dozens of, you know, we've had dozens of articles on Universe Today about exploring lava tubes on the moon. So definitely check that out. I've interviewed lots of people here on the channel about it. Hoppers to jump around the outside of lava tubes, as well as cave explorers on Earth who are sort of using their experience of exploring caves as like what we would need to do to be able to explore caves on the moon or Mars. Known unknown IDR. Could we refuel James Webb from fuel made on the moon? Maybe, but it's probably easier right now to just refuel James Webb from fuel made down here on Earth. You launch a rocket, it docks with James Webb, it uses the existing, you know, the connectors that put it on the top of the upper stage, and you should be able to either have a, you know, a new propulsion system that sits on the back of it and that now acts like the propulsion system for James Webb, or you can actually, you know, it has all the little fuel connectors on it. So in theory, you could put fuel back into it. So, you know, nobody is planning to do this, but it's not impossible. It just, you know, requires the will and someone willing to spend the money to be able to carry this off. I wonder what would the US do if, say, China offered to refuel James Webb? Would they turn them down? I wonder. Church discography. What is the oldest tree on your property? They're all really young. I mean, there's some trees that are probably about 80 years old, and there's a couple that have got to be a couple of 100 years old that were left, but most of the trees are about 30 years old. They're all the same age. They were all planted, Douglas firs, a meter apart, and they are crowded, and I have to cut them down, as many of them as I can cut, and then pull all the limbs off the bottom and wood chip up all of the debris to lower the fire risk on the property. So that is my number one concern, is the fact that this property could light on fire in a bad, you know, on a bad fire year. Frosty Winnipeg, why hasn't NASA or ESA tried to GoFundMe for a mission? Just because, how do you fund a $10 billion GoFundMe? You know, like it would be impossible. Like there are private donors that are willing to provide a few millions, maybe even tens of millions, like the Sloan Foundation or the Simony Foundation, the Gates Foundation, but billions of dollars? No. And it'd just be so. Really, government is the only way to accumulate the funds for those kinds of projects. Skygunner777. How much would it cost to put the equivalent or greater version of Vera Rubin in space, even if it took multiple missions to build? I mean, you could probably do it as a single spacecraft, right? It would just, once you're out in space, then you can observe the sky more quickly. You don't have to deal with the atmosphere. So I think, and Nancy Grace Roman is pretty close to that. It has a very wide field of view. It's an infrared telescope. It's not performing a survey in the same way, but it is doing a large scale survey of the universe. So it would absolutely be possible to create some version of Vera Rubin. Could you have a car, something that is the size of a car as your camera? Yeah, theoretically. Like maybe when Starship flies, it could, or New Glenn could carry something like the Space Vera Rubin telescope. And it would be amazing, right? Like maybe it would be able to see the entire sky. It wouldn't be limited to just the southern hemisphere. It could see the entire sky. So, maybe Vera Rubin is a pathfinder to a future space-based Vera Rubin. I mean, like all of this stuff, like all of these ideas, all of these missions that we all want, we don't get to have them because we spend money on the military, that we spend money on, all kinds of things that humanity spends money on, which you may consider to be of a lower priority than really cool space, but the rest of humanity doesn't see it that way. So we're in this kind of funny place that, maybe 5% of most countries' gross domestic product is spent on research. And some may spend a little more and some spend a little less. And the nations that have done the best are the ones that have spent more, over the long, that because it accumulates, right? The knowledge accumulates over decades, over hundreds of years. And the US is the best example of this, right? They were for the longest time the greatest spenders on science. And they are the most, the highest GDP, the largest economy in the world. And a big part of that comes from a lot of people, but also that they invested in science and technology. So, and yet we're seeing a decrease in budgets right now, which is unfortunate because that means that a lot of this kind of stuff, like you wouldn't get a Vera Rubin in the future if, under the current decreasing budgets. So I don't know what the answer is. I just, whenever I people are like, oh, wouldn't it be cool if we had yes, it would be cool if we had that. But right now, unfortunately, we're not even going to have the stuff that we were supposed to have. Not to mention the cool ideas that would take us to Enceladus and under the ice on Europa, and to launch a telescope that will allow us to directly observe habitable exoplanets. Anyway, but I digress. Drew D, who spends more on science than the US? Right now, nobody. The number 2 is China. And it's like they spend about 75% on science that the US spent. Like that, we actually did an episode of Astronomy Cast today and talked about China's budget, like space budget compared to the US space budget. And, about 30 years ago, China went all in on leapfrogging technology. Like instead of trying to catch up with the US and the rest of the world, they went for what they thought was going to be the next technological revolution, which is going to be solar panels, robots, miniaturization, the electrification of everything. And it looks like that's worked. Like it looks like that was the right call. And especially now, we're seeing the US drawing down its investment into renewable resources and electrification, electric cars, that kind of thing. So, but yeah, I don't know the exact funding. Maybe somebody can look that up during this chat. Plumax 54. How did life begin? We don't know. Good question. Decoded PR, how many nuclear reactors do we need on the moon? It just depends on how much power we want to be able to have on the moon during the nighttime. So during the daytime, solar power is great. It's all you need. Plus, you're out in the sunlight, and so you can stay warm. The trick is that you need to be able to have base load power, something that will keep you going during that 14-day lunar night. What is the solution to that? Nuclear reactors are the solution to that. And so you could build a fission reactor. And fission reactors have been tested in space. The Soviets tested 22 of them, and the Americans tested 1 fission reactor in space. So this has been done. And there might even be others that we don't even know of. They're classified. So you could absolutely take a fission reactor that would provide you with thousands of kilowatts, hundreds of kilowatts, maybe 1,000 kilowatts, a megawatt on the surface of the moon. And then you would have enough power to be able to do with everything you need. When you think about space missions, right? Like, what are the top 3 priorities? They're always power, power, and power. If you can get power, then you can do a lot of other stuff. But if you don't have power, then your spacecraft dies when the sun goes down below the horizon. It's the last show. Are we going to hear about something on the shelf? Do I have anything else? I don't think I have anything else that's interesting on the shelf. I feel like I'm looking right now, looking at everything that's on the shelf, and I've explained it all that's relevant. Yep, I'm sorry. I clearly need more things for the shelf. Mr. Tootie, have you interviewed Sarah Walker about the origins of life, assembly theory? No, I haven't. I talked to Lee Cronin I did an interview with Lee Cronin a couple of years ago, which was great. He's a party. So much fun. But I haven't talked to Sarah Walker yet. Like, he's one of her longtime collaborators. It's funny. She is becoming so popular that I'm less interested in interviewing her, because it's just like, well, she's really busy and she's had a chance to explain her ideas and her philosophy and her work and all of that. What could I do to add to the conversation? I want to find people you've never heard of, who are working on stuff you've never heard of. That's sort of, as opposed to another interview with her. But, obviously if she reached out and said, hey, Fraser, let's do a chat, I'll be like, I'm in. Sorry, just looking through the questions. Frosty Winnipeg, a sci-fi movie that you like that most others don't. Okay. All right. I got one that you're going to think is hilarious. Green Lantern. I like Green Lantern. I didn't love it, but I thought it was fine. I liked it. It had Ryan Reynolds. He's hilarious. We grew up in the same city, by the way, at roughly the same age. So we both grew up he was in Langley, I think. And I grew up in Vancouver. And I think we're about the same age. And Green Lantern is my favorite superhero. I really liked the Green Lantern Corps, the Alan Moore series, the Alan Moore, writing the Green Lantern Corps was just peak. It's like sci-fi, space opera, but it's also superheroes interacting with the rest of the DC universe. That's my absolute favorite comic book series. Alan Moore, Green Lantern. And so, yeah, seeing the Green Lantern done in that form was pretty great for me. I liked it. And like, it was a mediocre movie. Like, I get it had all kinds of problems, but it was great to see a lot of the ideas thought through by Alan Moore showing up. I guess, and then he did The Watchmen, right? But yeah, that's my that's my sci-fi movie. That's the sci-fi movie that may cause a bunch of you to unsubscribe from the channel. Well, there's like someone being mean in the chat. So Beeb Does is saying, everyone likes to criticize, but they won't look at one little pic. I've sent it to JPL and NASA. So like I get unsolicited emails by people who think they've seen aliens or think they've come up with a new theory for the universe, or all kinds of stuff. Every week I get, maybe a dozen emails every week. And I'm like ill-equipped. I have to delete all of it because I'm not a scientist. And so I can't tell you whether or not this stuff is real. And I know for the scientists, it's even worse. And yet each thing would take hours, weeks, maybe even months of work to really get to the bottom of a thing. And so scientists have to figure out how they're going to prioritize their work. They have to choose which research to let in and be able to study. And so they have to be very, very selective, because like, how do you, we all have, if people were knocking on your door, B-dubs, every day, a couple of times a day, and you knock at your door, be like, hey, B-dubs, I got this theory I want you to take a look at. I'm going to need the next week of your time. After a while, you'd be like, I'm out of time. I don't have any time to do this. So the way you get through that is that you actually like go to school and you understand the work as well as the scientists do. And once you have, then you'll be able to speak their language and be able to demonstrate that you've done all of the things that they would have done to figure out whether or not this thing is correct. And then they'd be like, yeah, did you check this? You're like, yeah. Did you check that? Yeah, I checked that. Did you check this? Yeah, I checked that. Okay, great. Well, then maybe you are into something new, maybe something fresh. Let's check it out. So unfortunately, there's no end run around this process. If you want people who are serious to take you seriously, you have to demonstrate that you have put in the work. And that's what it's going to take. But cool ideas, incredible discoveries can come out of nowhere. They can come from anybody. So you just have to be able to have done the research, done the work. And I don't know what you're specifically talking about, but the way you've got your backup in the chat, I've seen this many, many times before. Yeah, perpetual motion machine designs. Theory of everything, warp drive designs. Evidence of aliens. Are we on the next page? Is that what's going on here? Oh, we're totally on the next page. Okay. Oh, maybe we're not. Okay, we're not on the next page. Fermi paradox solutions. Yeah. Singularity engine plausibility. 0 point energy systems. Yeah. Wow. Big crowd tonight. Scotty Cartercom, what is your favorite planet and moon and why? Saturn and Titan. Why? Like, obvious. I have to explain this. Saturn has rings. Titan has like an atmosphere. It's crazy. So yeah, Saturn, Titan and Saturn. And they would be my favorites even if they were separated, but they're together. And then my other like favorite weird moon is Iapetus, which is also a moon of Saturn. So everything is in the Saturnian system. Richard, could we send a magnifying glass to a distant point where our telescopes could use it for a gravitational lens? So could we send a magnifying glass? Well, I mean, that's a telescope. What you're describing is a telescope lens. So, telescopes have lenses. And so could you send a telescope lens out into space and then use it as a telescope? Yes. Yes, you could. But you wouldn't be using it for gravitational lensing. You would just be using it as a magnifying glass, as a lens. You wouldn't need the magnifying lens if you were able to use the gravity of, say, the sun as a gravitational lens. That one. Edward Slug, why hasn't James Webb done an equivalent 10-day ultra deep field like Hubble? Telescope time is rare, but it's been going over 3 years now. I want to see how powerful JWST really is. It's just because they're still too busy. Like, it's not the top priority. And like, we didn't see Hubble do its deep field immediately. It took a while. And that's because there are more important observations to make before you do the James Webb Deep Field. But there are a lot of surveys. So there's the JADE survey. There's surveys, Cosmos Webb survey. So there are mini versions of what will eventually become the James Webb Deep Field. And part of they just have to understand how to use this telescope better. And then eventually, when they're ready, they will do it. I've talked to researchers directly about this. I've asked them this question, and that's the answer. The answer is we're not ready. We have too many priorities. We're working on other things right now, but don't worry, it's going to happen eventually. Circ 49, how long will it take for a comet disturbed in the Oort cloud to make its way to the inner solar system? It takes millions of years. Blasty McBlast-faced. Blasty McBlast-blast. How do we even detect neutrinos? Does a detector have a neutrino-resistant metal? Because that would be super useful for sailing in space. No, what happens is that neutrinos don't interact with anything, but they can occasionally interact with something. And so when they're going through a large, volume of water, a cubic kilometer of water, ice, at the South Pole, then they will occasionally interact with an atom of water. And then you get this sort of explosion, this cascade of particles that goes downstream. For the neutrino comes in, hits a water molecule, detonates, and you get this spray of particles that goes out. And that there are these detectors embedded in the ice in the neutrino observatory that detect all of these particles as they sweep past the detectors. And then they're able to figure out, what was the direction that the neutrino was coming in and what kind of energy did it have, and then what did it turn into. Brian Bach 435. Where is your sense of outrage over the proposed massive cuts to NASA and science in general? You should definitely listen to the Astronomy Cast. So my outrage is scarcely controlled right now. I am, but also we're in this kind of limbo, which is that the the White House has made its budget request to Congress, and Congress has yet to actually sign the budget request. And so we don't know what the final outcome of this is going to be, and we don't know which missions are going to actually get cut. So I've reported on, if you go back, like, people are complaining that my channel is overly politicized because I've been reporting on the budget cuts. But all I can do is report on the budget, on their proposed budget cuts. But I don't know, like, I know what the percentages are of what the White House is asking, but we are not at the point where Congress has approved the bill, signed into law the budget cuts, and then people have to do the grim work of actually canceling the missions and letting go of the staff and now we're seeing a winnowing of the staff at NASA. People are taking early retirements, buyouts, and we know that layoffs are coming, but we're still, like, of all of the stuff that's happened since the new administration took over, a lot of cuts, a lot of things have been bad. NASA specifically, it's still, the hammer hasn't fallen yet. And so all I can do is report on the things that have actually happened. But I promise I will slowly and brutally tell you with a straight face that beloved missions have now been canceled and everybody's been fired. And that thing that we all talked about and the thing we all wanted to happen is now not going to happen. So the way I, like, when I'm not being a journalist, what do I think? I think this is crazy. I think this is a terrible idea. I think that NASA and just, like, basic science research is one of the most important things that a nation can do. That this is, we live at we stand on the shoulders of giants. We are now here because of the collective work, scientific research done by generations of people, that we have all of these modern conveniences because people year after year after year studied the basic nature of reality and gave us these incredible insights. And we don't know what they turn into. You have to keep doing, you have to trust in the process. You have to follow your training. And it appears that this is no longer going to happen in the United States, that you're going to have this drawback from investigating reality into something that is a lot more to follow on to specific ideologies. And that doesn't sound like it's a wise idea to me. But I'm a Canadian, so our budgets are expanding. Our investments are growing. Our investment into our space agency is growing. The commitment to hiring people who are being let off from other universities is growing. So, what is a terrible time for the U.S. science research could have benefit for other countries. And so I think that, my outrage is, it's going to drip, drip, drip. I'm going to drag all of you through the sadness of the loss of the missions and the science, item by item, cancellation by cancellation, day by day. That's how this is going to feel. So I think that right now, we don't know. It's all Schrodinger's cat. We don't know if New Horizons is going to survive or New Horizons is going to be cut. We don't know if OSIRIS-REx is going to be canceled or if it's going to be able to maintain. We know that Nancy Grace Roman is probably going to continue. We know that Dragonfly is probably going to continue. But a lot of this other stuff is just, the budget was this. The new budget is half of that. Stuff's got to get cut. What's going to get cut? We don't know yet. So when we know, then every time, like, this is my guarantee to you, my personal 100% guarantee is I will tell you directly, without sugarcoating, exactly what got cut. This got cut. That got cut. This is never going to happen. This mission, this team has been laid off. That technology has been canceled. This contract has been canceled. I'll tell you each one of these things. And, you can probably sense my position and my opinion about those things without me needing to get worked up and having a tantrum about it, right? I'm just going to let my reporting speak loudly, and I think that for like a lot of people who they've sort of mashed together their political ideology and their yes, it's 7:00. I know, but I'm kind of you started me ranting, so I will continue. But yeah, but like for a lot of people, like their political sort of connection is stronger than their advocacy for science and for space. And I'm hoping here in this community that is new. Like I'm sure there's people who are watching this right now who are, on the conservative side of the spectrum, and there are people who are on the liberal side of the spectrum, and there are people right down the middle, and there are people who are more libertarian, whatever, right? But the thing that we all agree is that we love space and we love science, and we think that research is an important thing. And just imagine to yourself if the shoe were on the other foot, if your preferred government made the kinds of cuts that are happening today, would you fall in line, or would you react? Would you write your congressman, right? What would you say? And that should be a way to guide yourself through this time about how you should feel about this kind of stuff, no matter what political affiliation you have. Just decide if you think that these are wise cuts for the future of the country, of society, of humanity. But, again, I'm Canadian. So currently, Canada has its own set of issues with the United States. And so, like a lot of people are looking at what's going on in the United States as this is an awful thing that we're doing to ourselves. And for those of us who are not Americans, we're watching this and we're saying, this is a thing you're doing to yourself, but you're also doing this to us. And that we were once friends. We were once close allies. We were once, the guy who had your back. And that doesn't exist anymore. And so my perspective as a Canadian is different from my perspective as a journalist, and my allegiance to space and astronomy in general. And so I think as the future rolls out, and as I am going to report the changes that have been made. I'm also going to report on the growth and the accomplishments made by the Chinese and by the Europeans and by the Indian Space Agency. It's a bigger country, a bigger world than just one country. A lot of things are interesting that are happening around the world. And I think it is regrettable what's happening in the US, but it's a bigger world and a lot of stuff is going on right now. So, but if this is a concern, you should take action. If you are an American and you're watching this and this is of concerning to you and you haven't already, please take action to make this change. Talk to your elected officials and tell them, I voted for you, but, right? If you're, especially if you voted for them, right? If you're Republican and you voted for them, but you also want to have space exploration and you want to have missions going to Venus, call your congressman, call your Senate, tell them that, you're fine with all the other stuff, the tax cuts, whatever, but don't cut the space. Don't cut the NASA. Keep that going. So good luck with what happens. And I promise, for those of you who are waiting for my outrage will be delivered to you week after week, drip, 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 like a water torture of all of the stuff that's being canceled. So, all right, we did it. We reached the end of the season. And so now I'm going to sign off. But before I do, thank you everybody for hanging out with me week after week after week here on the channel. What fun. Like I really enjoy this, and I do miss it, but I also need a break. But I want to give a huge shout out and a big thank you to the moderators here who are also going to get a break. So Zapfan and John Suffield and Arjone are here. And I really couldn't do this without their help. And so thank you guys for that. Please give them a shout out. A big thank you in advance to Chad and Anton, who are going to be editing all of this in the coming week. I'll be here all summer long producing more space news, interviewing some really cool scientists, and we'll be producing a lot more content. And hopefully I will get this stupid telescope to behave, and I'll be able to share the universe with you. All right. Thanks, everyone. And I will see you all in 2 months. Thanks, everyone.